We are in chapter 8 of basic chemistry, and this is on chemical reactions. And so today's lesson is on reaction types. I think you'll find this to be an easy concept and no big deal. There are various types of reactions that when molecules or elements break apart like Legos and then reconfigure, various types of things could happen. Okay, so for instance, let's imagine that I have two red Legos and a blue Lego, and I put them together and make a combination of the two red and one blue. So I've combined those together. So I had either two reds connected together and one blue separate, or all three separate. That would be on the left. That's a reactant. And then at the end of the reaction, I would have one toy that had two reds and one blue all connected. Okay, that's a combination reaction, and you'll have those exact kind of reactions when you have elements. They will combine to make something. So normally you're looking for the left side of the equation to have more than one thing, and the right side having one thing, where they come together to make something. Okay, that's combination. Backwards of a combination, okay, so let's say at the beginning of the reaction I've got a molecule that's got two red Legos and a blue Lego in it, and I break off the blue Lego. Okay, and at the end I have a blue Lego and two reds. Or I break them all apart and I have two reds and one blue. Okay, so I can do that too. That's opposite of a combination, and that would be a decomposition reaction. All right, so that is one. Okay. Another type would be a single displacement. Okay, so you've got two red Legos together, and a blue one comes in, pulls one red off, and connects to the red, and then leaves you a red. Okay, so one Lego is pulled off, the other Lego comes in and combines with it, and then kicks the other one out. So that would be a displacement. So a single displacement is when it would be like prom date, and suddenly now your girlfriend has a new boyfriend at the prom. So sad. It happens. Okay, so you two are a couple, and then 2 seconds later you're by yourself and your date is going off with somebody else. Okay, it'll break your heart. Okay, just deal with it. In any case, that is a single displacement. There's really only two more. The only other possible combinations would be, let's say you have two couples and they switch. Okay, so the positive cation is joined with an anion, and another positive anion, a cation, is joined with an anion. And then you put them in water and they all dissolve, and then they come together in a different configuration. So they switch the positives switch. Okay, so it's switching partners. That would be a double displacement. And then the last one is a combustion reaction when something is burning. When something is burning, you're going to have oxygen somehow, O2, as a reactant, and at the end you're going to have carbon dioxide and water. So whenever anything burns, you're going to get carbon dioxide. Remember, that is a greenhouse gas. Whenever your car burns gas, or you burn fires or whatever, that's a carbon dioxide. Even when your body is burning food in your cells at body temperature, you expel carbon dioxide gas because it's a combustion reaction. Okay, plus water vapor. All right, so let's look at these various types of reactions. Okay, combination, coming together, decomposition, breaking apart, single displacement, one guy kicking another guy out and taking his girlfriend, double displacement reactions where they switch partners. And then I would add one more, and that's combustion reaction where something is burning in air. So let's look at them individually. Combination reactions, you are making one thing out of two or more things. So on the left, your reactants, there's multiples, but on the right, you're going to have a single product. So here's magnesium plus oxygen gas yields magnesium oxide. Okay, one thing on the right, two things on the left. Sodium, metal, chlorine gas comes together, makes table salt, sodium chloride. Okay, sulfate ion plus water, sulfur trioxide plus water yields sulfuric acid. Okay, so that is a combination reaction. This is just an example of magnesium oxide. I would have done this for you if we were in class together. Magnesium metal, it's just a regular metal. There's nothing but magnesium. Oxygen is in the air. Anything that burns is burning in oxygen. It's essentially a reaction with oxygen. So you have oxygen gas, magnesium metal. If you light that metal, it will burn with tremendous brightness. In fact, you have to look away. You can't look straight at it, or you actually can burn the retinas in the back of your eyes. You certainly don't want to be blind most of your life just because you went to a chemistry class in 9th grade. But at the end of this, the oxygen actually combines with the magnesium, and you have a combination. You have a reaction, or you have a molecule. It's actually a formula unit of magnesium oxide, where it's no longer magnesium metal. It's no longer oxygen gas. It is a combination of them where they're actually stolen electrons and reacting together. So that's an example of a combination. Okay, let's look at decomposition. Decomposition's backwards, where it's breaking apart. So you have a reactant normally, and it breaks apart into 2 or more products. So if you have, in this case, mercury oxide, it breaks apart into mercury metal plus oxygen, or potassium chlorate breaking apart into potassium chloride and oxygen. Okay, so different ways to do it, but decomposition decomposes. It breaks apart. That's what decompose means. Okay, so here's an example. This is mercury 2 oxide. Okay, mercury 2 oxide, where it's a combination. So it's actually a chemical compound of mercury 2 ion plus oxygen anion together, and it breaks apart into hydrogen gas and oxygen gas, or mercury metal and oxygen gas. Okay, here's an example. Classify the following as combination or decomposition. All right, we have a hydrogen gas, and bromine gas yields hydrogen bromide. Okay, so 2 going to 1. What do you think? Combining, so it's a combination. Okay, aluminum carbonate breaking apart into aluminum oxide plus carbon dioxide. All right, so you have one reactant, more than one product. That's decomposition. Okay, aluminum and carbon coming together to form aluminum carbide. Okay, so that's combining, so it's a combination reaction. Nice and easy? I figure this is easy. I would say this is pretty simple. Okay, so let's look at stealing someone's girlfriend. Never do that. It's a terrible, terrible thing. Okay, someone will punch you in the jaw. In a single replacement reaction, one element takes the place of a different element. Okay, so what you're going to see is that some elements are more they're more active, I guess you would say, than another one. So it'll combine with something, but if there's another element that is more attractive to it, it'll kick the one out and join with the other. Okay, so it's all about energy. And when the compound has lower energy, it's more likely to happen. Okay, so here in the case, you've got hydrochloric acid and zinc metal. So if you put zinc metal into some acid, it'll bubble. And that bubble is hydrogen gas, because what's happening is the zinc kicks the hydrogen out and joins with the chlorine and becomes zinc chloride. So it disappears. The zinc actually degrades into the acid, and you can't see the zinc anymore. It actually just dissolves and then becomes part of the solution, but you get bubbles, and that bubbles is hydrogen gas coming out. Okay, so that's single displacement. The A is kicking the B out and taking C as its partner. Okay, if you have copper sulfate, which is blue, it's a deep blue color, and you put some iron metal in it, you put a nail into some copper sulfate, what'll happen is the copper will come out and you'll get reddish brown flakes on the bottom of your jar. Okay, and the iron will start dissolving. The nail will actually break down, and as it dissolves, you will have iron sulfate. So the blue goes away, you have a different color of solution, and then you have the copper that wasn't there that just kind of falls out of the liquid and onto the bottom of the jar. Okay, so that's single displacement. Here's an example. zinc and hydrogen chloride. So this is HCl, this is acid, hydrochloric acid. You put it in and you're going to get a furious bubbling, and that bubble is hydrogen gas that then goes away, and the zinc actually breaks apart and becomes zinc chloride solution inside the jar. So you don't end up with hydrochloric acid anymore. I still wouldn't drink it if I were you. All right, last one here is double displacement. Double displacement, they both trade partners. Okay, so if A is positive and C is positive, they switch places. So C will then join up with B and A will join up with D, and you'll have different stuff. And remember, if you have different combination, you have different properties. Okay, a different compound is different than the starting stuff was. Just because you've got silver in it means nothing. Just because you have chlorine in it means nothing. Whatever the compound is has properties that you can describe or measure or something like that. Okay, so here's an example. Okay, so here you've got sodium sulfate. Okay, you've got barium chloride. So the barium is going to come off the chlorine and go to the sulfate. The sodium is going to come off the sulfate and go to the chloride. Okay, because they're more suited to the other one electrically or energy-wise, and so they will break apart. Now, if you've got a partner that would rather have you than someone else, then they're not going to break up with you. That's the way it works. Okay, that's the problem for me. That's the problem for you. You have to be better than your competition. But if you're better than your competition, they will not break up with you. It's likewise with chemistry. If you have something energy-wise, which gives the reactant a very low stable energy, then it's not going to continue reacting. Remember, it only continues to react as the boulder is falling down the hill. But once it's at the bottom, it's stable. It doesn't need to continue to react. It only reacts in order to make it stable, energy-wise. All right, so classify as single displacement or double displacement. Now this is as easy as it can be. Do you have 1 plus 2? Here's aluminum, this is 1. Here's hydrogen sulfate, that's 2. Okay, and now the aluminum is joined with the sulfate over here, and your hydrogen's kicked out. It'll always be the first part that's connected that will be by itself at the end. That's a single displacement. The aluminum came in, kicked out the hydrogen, and the hydrogen gas bubbles out, and you end up with aluminum sulfate. So that's single displacement. When it's 1 plus 2, yields 2 plus 1. Single displacement. Double displacement's even easier. You have 2 and 2, and they switch places. So the silver joins with the sulfate, and the sodium joins with the nitrate, and you end up with a flip-flop. And that's all. Okay, what about this last one? Carbon, iron and oxygen, iron, carbon and oxygen. Single displacement. Carbon is kicking out iron. Iron becomes iron metal, and the carbon joins with the oxygen. Okay, makes carbon monoxide in this case. Okay, so here's an example of all. Combination. They just use A's and B's. I like it. It makes sense to me. A plus B, meaning the positive is A, the negative is B. AB is the ionic equation. AB breaking apart into A's and B's. A and BC. The A comes in, kicks out the B, and takes the C, right? And then double is when A, B, C, D, and then A and C switch, right? That is the review. All right, combination, decomposition, single and double displacement, okay? Barium, nitrogen, barium nitride. Combining, so that's combination. Silver, hydrogen sulfide, silver sulfide, hydrogen. Silver's coming in and kicking out the hydrogen, that's single displacement. Silicon oxide, hydrofluoric acid, silicon tetrafluoride, water. Okay, do you see that's 2 and 2, 2 and 2, so that's double displacement. They flip-flopped. Lead chloride, potassium sulfate, potassium chloride, lead sulfate. They've just switched. That's double displacement. Then you have potassium carbonate, breaking apart into potassium oxide plus carbon dioxide. You see it's something breaking apart into 2 or more things, so that's decomposition. All right, I hope you're learning a lot.